Hi, it's Sam. In this video, we're going to make a polyphonic synth using MC objects, which are really great because they make it very easy to make polyphonic synths or polyphonic effects without having to use poly tilde, and it's just overall pretty easy to get started. And I'm going to be showing you how to kind of optimize your code so that it will work properly. So let's start off by actually making a kslider because I'm going to want to make some notes here. And I'm going to put this into, I'm going to right click the left inlet and select mode and change this to touchscreen for now. And this is just for testing it as we go. And we need to send everything to mc.noteallocator. This is what's going to manage the notes for us when we create the rest of the synth engine. So for this, we're going to give a number of voices. So let's add that as one of the attributes. And I'm just make this an 8-voice one. And then I'm going to turn voice stealing on by saying steal 1, so voice stealing is on. So what we send to mc.noteallocator, it says, let's see, a busy signal, MIDI event, or MPE event messages, and I'm going to use a MIDI event for this here. And we're just going to make the MIDI format object, and out of the right outlet, you can get the MIDI event message output. And that's what we're going to plop into noteallocator. And for MIDI format, we can pack together the velocity and pitch. Okay. So we're going to pack in the velocity and the pitch and then put that to MIDI format, and then that will give us the MIDI event message that noteallocator is expecting. So that's all good and well. Let's start to put together the actual synth now. And kind of the main parts that we're going to start with is the envelope and the, the actual sound source of the synthesis. I'm just going to use a saw wave to make it very simple. So let's make a mc.saw. And what's important now is that we make 8 channels. We have 8 voices, so we're going to make the channels attribute 8. And this is what's special about the MC objects, that you can set the number of channels that they have. And so we want to make sure that it matches the number of voices. And then let's see, let's pop this down. And you could dynamically, I believe you can dynamically just change, if you wanted to change the number of voices and then change the number of channels to match that dynamically. So if you wanted to be able to change how many voices there are, like 1, 2, 4, 8, 16, whatever, you could have a menu that you can change between the number of voices and dynamically change the voices message to noteallocator and then the channels message to the MC objects that use the channels attribute. So we need our saw. This will just be the kind of sound source for our synth. And what we need to use now is another specialized object, which is mc.target. Now, mc.target is used with noteallocator to send messages to the objects we want to control in the path here. And for saw, we're going to want to tell it what pitch to play. And we want to do that with we want to send that pitch to the correct channel. The nice thing about MC, how this works with noteallocator, is that we can keep the channels that we're not using muted, so we can save on CPU by not having those sending out data when we're not using them. So if we're not using any notes, then we want to save on the CPU usage by just not sending out data on those 8 channels. So we can just turn on those voices, send out data when we are using a voice, and when we're not, we can make sure to mute it. So how do we do that? We need to send the instance, the voice number, to the right inlet. This is the target index, the right inlet of mc.target, and we can get that from the rightmost outlet of mc.noteallocator, which is the voice number. And so those are going to match up nicely together, and I'm going to make a little message box here so we can, the right inlet of that, so we can view what the voice number is. And what we're going to send to mc.saw, we want to send what the frequency is of the note. So out of noteallocator, the very left here, we're going to get the note on pitch and velocity. So we need to unpack that. And by default, it's just going to give us 2 values. So we can just leave the arguments blank there. And we're going to send the left outlet, which is going to be the pitch. We can just send that to an M2F MIDI to frequency. And that will give us the frequency that we can then send to the mc.saw. And again, it's going to be sent to the instance that we are, that's currently active based on what voice number comes out of the rightmost outlet of mc.noteallocator. And then we're going to need to send the velocity somewhere else. And what that somewhere else is going to be an envelope. So now we need to make sure that there's something controlling the amplitude here. So we're going to first create an MC multiplication and plug our saw into that. And then we can put our ADSR. Oops, that's not what I want to do. I want mc.adsr. And let's just give it some values, 5, 100, 1, and 10. So we have let's come default envelope like that and make that 8 channels. And here's where I want to mention a very important point, which is that everything, when it comes to the channels, the number of channels that you're using, everything's going to go downstream. What do I mean by that? What I mean is that if you have 8 channels in this upper object here, I've got the mc.saw here. This is the first MC object in the signal chain that is using the channels attribute. And I gave it 8 channels. So everything downstream from here will output 8 channels, which is useful because if that means you don't have to send, if I wanted to change the number of channels, I wouldn't need to send that channels message to every single object, and I wouldn't have to worry about matching the number of channels to every single object downstream from whatever first object has the channels attribute. So if I look at the output of this MC multiplication object, let me just use like an MC number, number. If I plug this in here, you'll see that it has only 1. That's probably because, let's see, why is that? It should have 8. I swear it will. Let's figure out why. So let's go and add in the rest of the parts here, starting with another target message. So we need another mc.target because we're going to also be targeting instances of mc.adsr. And again, we can just send the voice number to the right inlet. And then we're going to send out the velocity. But mc.adsr is expecting a value between 0 and 1. So we're going to have to scale the velocities. Velocity is going from 0 to 127. We'll scale that from 0 to 1. And then that will give us the expected value to ADSR. So unpack into scale. And that's all set. And then we need to get another unpack here because out of the next outlet, we get the note off pitch and velocity. And for that, we can just send the note off message straight to mc.target. We could go through the stale, but it's always going to be 0 because note off is always going to be 0. And we don't need the pitch in this case because there's just not going to give us any information. We need the voice number is being targeted already. So we don't need to pair up the pitch for any reason. So that will take care of the note on and note off. You know what? I know why this is not showing the correct number of channels. That's because the audio is not on right now. And so let's go over here and turn audio on, and now it's correct. Okay, so that was the issue. So once the audio is on, now it's showing that there's 8 channels coming out there. Okay, so we have the, again, downstream from mc.saw, which has 8 channels, we have 8 channels also coming out of the MC multiplication. So that way we don't have to worry about adding the channels attribute to all the downstream signal path here. Now, part of the way that mc.noteallocator is able to allocate the voices and turn them on and off is by using the current volume and or state, I guess, it's looking at the amplitude, and it's using that to kind of know what the state of that voice is, if it's on or off, it's available or unavailable to be used. So out of the MC multiplication, we're going to send this back into the note allocator. Let me clean that up. And so it's going to use the current state of the voices, the channels, to be able to allocate the incoming note to the correct voice, kind of like an inactive voice. So let's see this in action by, let me just create a couple of objects here. We're going to use MC mix down and mix down the 8 channels into one. We'll get rid of this for now. And then from there, we can just unpack and send this to, actually I can just say MC unpack 1 because there's only 1 channel now, and then send this to a live.gain. We're just going to send it to both because this is all mono. It's just this mc.saw. It doesn't matter. There's no stereo information there. And a easy DAC. And let's just make sure to turn this down because I don't want it to be super loud or grating. You can see it's going to cycle through the voices. And if you're unaware, on kslider, the higher you place your cursor on the note, the higher the velocity, the louder the note will be because the velocity value will be higher. So cycling through all the voices, and we can use, no, it's not really like an easy way maybe to view all of the active voices. We could use like MC scope. And this would, let's see. Okay, yeah, you can see one of them is active. They show like a faint line of the voices that are not currently selected. Okay, so what I also wanted to demonstrate is a quick way to test the polyphonicness of this patch. So if you use the chord message, we can just make a quick C major chord. So chord, and then this will be first the pitch, so 60, the MIDI number 60. And I'm just going to make 90 be the velocity for all 3 pitches. So 60, 64, and 67. And I'm just, again, putting the velocity as 90 for all 3 of those. And then I can use the flush message to turn all of these off. And then just using this, we can see how it's working polyphonically. You can see that looks like voices 6, 7, and 8 are active right now. Then turn it off with flush. And then for further testing, I'll just make one for 60 by itself with 0 for being able to turn it off. And for 64. And this is just so that we can test some other features we're going to add here. So let me just put these all up. Just so if you don't know this, one kind of easy way to connect things, you can grab the inlet so that I don't have to, I'm sending all these to this inlet, so it's much faster if I just select from this inlet, and then I press and hold Shift, and then I can click and it'll keep this chord. So I'm pressing and holding Shift and then clicking. And this is a much faster way of being able to connect from all to the same inlet, in case you didn't know that function. Okay, so moving on, let's take a look now at the other aspect of this I wanted to add, which is just a quick low pass filter and some modulation of the cutoff of that filter. So let's get a little bit of space here. I'm going to be adding one more object, which is mc.svf. So that's our state variable filter. And this is, I'm going to pop this in before the mix down into the first inlet, first outlet. So that's our low pass. And what else do we want to do here? We don't need to worry about the channels attribute again, because this is all downstream from our SAW and ADSR. And it's the second inlet, the cutoff, that we're going to be modulating. So let's start off by just creating a float box. This will be representative of the center value of the frequency. So let me just create a comment and say low pass frequency. And it's good to get into the habit of giving a default value using load mess, so that when you load up your patch, you don't have to worry about you can just start to make sound and not have to worry about setting the different number boxes or whatever you have dials to the correct value so that you get sound. So I'm going to set this to 12,500 by default. And now we can send this just to, we only need to use this as kind of the center value. And we're going to be using this for the cutoff by first sending it to just an MC sig, so that we can use a signal to modulate it. And since this is not going to be downstream from anything with the 8 channels, we need to, again, make sure to have the channels attribute, because this is its own kind of chain of signals. It doesn't know that there are 8 channels that are, exist elsewhere. And so I want to just add a little bit of smoothing here. I'm just going to use line, with 0. Oh, sorry, with 0 as a floating point number, so that it accepts floating points. And then I'm just going to have a 5 millisecond ramp here. Send that into line. Okay, this is just to smooth out the value changes a little bit to MC sig. And what you want to do with typically, with modulation is a very simple setup where you are both multiplying, kind of scaling a value, and then adding it. So we're going to use MC plus and multiplication. So basically what we're doing is we are scaling the center value by a certain amount that's going to be coming from, in this case, an LFO, and then we're adding that to the center value. So let's just give a little more space here. And then this is going to all go to the cutoff. So when we're scaling it by 0, this is just going to multiply by 0 and then add 0. And so we're just going to get the center value. So obviously that is fine. That's what we would want. And then we can start to add a little bit of modulation from there by just turning the depth up. So let's now add an LFO. And for this, we can take advantage of an object that is available in Max 9, or I guess a suite of objects, which is the Ableton DSP. We have mc.abl.dsp stereo LFO, which is pretty cool. And we can give this 8 channels, because again, this is going to be its own chain. And so we need to specify how many channels there should be. And this is going to act as our LFO, and we can set a few different things here. The frequency is obviously important, and also the, let's see, I actually want to get the use busy map. I'm going to keep it on for now. And the waveform, I'm just going to keep it as a sign for now, but with this menu, we can change what the waveform is from sine to other shapes. And I'm going to use load mess again. Like I said before, it's useful to have a value set up so that you can start to use your patch right away. So I'm going to just send this a 1 so that there'll be a little bit of movement to the LFO. If it's at 0, it's not going to do anything. And then I also want to add in the depth so that we can apply a certain amount that we specify of the LFO signal. So let's see, let me put this over here a little bit. And for this, let's add a floating point, and I'm actually going to go into the inspector here and say minimum is 0 and maximum is 1, just because I don't want to go above and below that. And I'm going to send this a load mess of 1 so that this will have full depth when I first start it up. And like before, I can just grab this code. I'm going to use the line just so I can have a little bit of smoothing. And I'm going to send this to MC multiplication so that we can scale the LFO. And we can actually, let's see, it would probably be useful to visualize this. So right now, I could even turn this up. Right now you can see there's nothing's happening, and that's actually what we want, because the voice is not on right now. There's no voices on. But now once I turn on, let's see, C, you can see that one of the LFOs just started. Let me get it to 1, 3, 2, 1. And now voice 1 is active. And again, this is the benefit of using this setup, is because it's going to be inactive when voice allocator is not sending anything out. It's using the busy map that we have set up via the MC system. And so now I can just plug this in, and we have some modulation of our cutoff. So I'm just going to add a depth marker here, or label, I should say. And now we should be able to try out the synth. So we turn up the frequency. Oh, it's maybe higher than I would like it to be. Now you'll probably notice that these are they have independent phase for the LFO based on when you start the note. So the LFO, you might like that. You might like that they're independent, and so that whenever you start playing the note, the LFO starts at that time as well. So you kind of have these out of phase sounding notes with the cutoff moving at different times. You can see here that they're not in phase with each other. And again, that's because of the busy map. Now, if we use the reset message, we could force them to be moving at the same time. But we'd have to do that every time that we're playing notes. Now it is like staying pretty well in sync now that we've used that, but this is kind of based on max messages here, when they're triggered. So it could be that they are triggered at different times, just because the nature of timing with max messages, or if I just were to do them separately, like with these two messages. Now it's definitely not in phase. Now, if you want it to always be in phase, it'd have to be running all the time. And that's where the busy map comes in. If I turn the busy map off, now I should also hit reset again to make sure that they are now all running. Now they should be running all the time. Yep, they're running all the time. Here you can see from the probing of the signal here, that they're all running at the same time. Again, you should make sure you hit reset if you're switching between using the busy map on and off. You should probably hit reset to make sure that they're all aligned again. And now since they're always active, they should always be in sync or in phase with each other. And I'm still kind of getting the benefits a bit here because of the MC busy map, because it's not sending out the signals from the MC multiplication here, because this is still using the busy map, but only the LFO itself is going to be always active. So I'm probably getting a little bit of CPU saving from this as still, regardless. But that is one way to make it so that they are always going to be lined up by turning that busy map off. Let me demonstrate to the depth. So let me just play a note here. Let's see, this is 6. Okay. Now if I turn the depth down, you can see that I'm just still going around the center point of 0. Can also turn this down. So that's nice that you can adjust the depth of the effect that way. So there you have it, a simple polyphonic synth using MC, which I think is really a great way to be able to set up some polyphonic instruments or effects, like I said, without having to worry about using poly tilde, and to get the benefits of the busy map in muting the channels that you're not using. From here, you could add more modulation, like pitch modulation. You could add effects. You could add panning. If you wanted this to have panning, you could, instead of using MC mixdown, you could use MC stereo, or you could use MC mixdown as well and just make this 2 instead of 1, and then be able to pan with the right inlet. I have my video about the additive synth using MC goes a bit over how to do panning using the MC mixdown object. Like I said earlier, you can use this basic setup of scaling the center value and then adding that scaling amount to the original value. This kind of setup, you can just reuse this for any kind of modulation that you're doing, particularly if it's bipolar. If it's going above and below that value, then this setup works nicely. I hope you found this useful and informative. There's a lot you could do with this from here, so I hope you find some fun ways to expand on this. Let me know if you have any questions or clarifications, if there's something else that you'd like me to cover. Otherwise, until next time, class is dismissed.